Evening, everyone. Welcome to our online talk this evening. It'd be a great pleasure to introduce Lucy Mitchell, who's going to talk to us actually from Ghent University, which makes us sound very posh tonight, from calling Scanning the Skies for Migrants. Before I do so, though, I will just flag a few kind of housekeeping things with regards Migweek. So tomorrow, the Visible Migration Watch is at the Bridlington Links golf course. That's just on the west side of South Dykes at 7:30 in the morning till 9:30. Again with Keith Clarkson, but he's not at home in Migweek for once. He's got his passport and he's coming to the Bridlington Links. So that's a heads up there. The guided walk is at 10 o'clock at the Lighthouse. That's fully booked. There is also a Cetacean Sea-Watch event at the Sea-Watch Observatory from 11 o'clock till 3 o'clock in the afternoon. Our next talk in person is on Wednesday night at Bempton. Unfortunately, if you've not booked, it is fully booked, and that's by Will Scott. I think I've covered most of the items that are happening tomorrow. It was a great day today in that the weather was nice. It was kind, sunny, and there were light winds. So I think quite a few of you managed to get out today, and there were a few birds as a result. Our first tundra bean goose of the year flew west this morning. The little bunting reappeared near Thornick Camp on the north side of the camp there, and that showed quite well apparently this evening. Certainly not to me, I was not seeing it at all. There's been a twite, again in the Lighthouse grassland area that joined our linnet flock. And interestingly, there's been an increase in redwing this evening. So perhaps that, or probably there will be quite a few redwing on that early morning watch in the morning. So redwing are increasing, light winds, I think birds are coming across today, and a handful of brambling as well. So all indicative of small numbers of birds arriving, particularly this afternoon. So that's where we are today. I think tomorrow is southeasterly, a bit stronger, so I expect quite a few things again tomorrow, and maybe the same on Wednesday and Thursday. So it's giving us a bit more of a southeasterly flavour than we expected 2 or 3 days ago. So you never know. Anyway, to tonight and Lucy, who's talking, as I said earlier, about scanning the skies for migrants. Lucy is an avian ecologist with a particular interest in migration, and as I said earlier, based at Ghent University in Belgium. She did a PhD in nightjars, looking at the diet and foraging behaviour during the breeding season, and she chairs the UK Motor Steering Group, which is all about tagging birds, and bats, in fact, that they can be tracked. I won't say any more than that because Lucy will know far more about that than I, but I shall hand over to Lucy now. Thank you.
Perfect. Thanks, Craig. I'm just going to share my screen and we'll kick off. There you go. Okay, perfect. So yeah, hi everyone, or goedenavond iedereen, which is what we say in Belgium. I'm based at the Ghent University, Universiteit Ghent, in Belgium, and I've been here for the past 6 months. But I'm going to be talking about MOTUS in the UK, which is something that still really interests me. It's something that I'm still very involved in and will hopefully continue to be involved in. MOTUS is a collaborative tracking technology that I first became aware of in my first postdoc. So back in 2019, after I'd finished my PhD, which I did at the University of York, and I went on to my first postdoc at the University of Hull and was kind of given the task of growing the MOTUS network in the UK with no money. So there was it was a real challenge, but it led to loads of networking and loads of kind of development and little bits of funding here and there. And it's still something I'm super keen on, and yeah, hopefully it can give you a quick overview today for the next, I don't know, half an hour or so, kind of give you why it's useful and what we've been looking at in the UK, and hopefully give you lots of ideas. And yeah, you're very welcome to ask loads of questions, which we'll hopefully be able to follow up on at the end. Okay, so we don't have a lot of data on small birds and mammals that migrate. So we know that loads of passerine species make phenomenal journeys in the autumn and the spring to and from their breeding grounds, but they're so tiny that we don't really have the ability to track them. Things like these amazing satellite tags and things that you put on raptors and storks and things. They're just it goes without saying they're too heavy for a twite or a goldfinch or an Nethusiast pipistrelle. But these species are making these incredible journeys. They're dealing with natural hazards on their migrations between their breeding ground onto their stopover sites. They might lose a stopover site completely, which might change their journey. It might change population dynamics. They're coming across anthropogenic development, not just wind turbines, but shipping and bridges and things like that. They're coming across things that might impede their migration. In order to conserve these species, these species make up a phenomenal amount of the biomass on our planet. They're really important, and we need to know where they're going, when they leave, when they arrive, how long does it take them, how varied are these populations and within different species. We just have so little information about our smallest migratory species. And in fact, the conventional migratory species, so there was a meeting this year, earlier, I think in February or March, but this piece of document is from February 2020, so it was just before COVID hit, all those years ago. And it actually states under the heading of improving ways of addressing connectivity and the conservation of migratory species, they actually actively encourage parties to disseminate and deploy a large number of energy-efficient, low-cost radio base stations to improve knowledge about connectivity affecting small migratory species. And that is exactly what MOTUS is. So MOTUS started in Canada. It was actually a collaborative partnership between Acadia University and Birds Canada. And so I think it was started in around 2011. It didn't really start to grow at any particular rate until maybe 2016, 2017, and the guys at Birds Canada and Acadia University produced a publication about MOTUS, and then people started, it was a bit of a sort of snowball effect. The more people that know about it, the more people get involved. And it really is an international collaborative network. We cannot solve the problems with migratory species decline and trying to conserve them on our own, like in our little bubbles, our research groups, kind of on our own. We have to work together. We have to help people collect data and do research and stuff like that. It's something that needs everybody involved. And this system really enables, like it says here, a community of researchers, educators, organizations, and citizens to undertake impactful research. And it's one of the really, really positive things about MOTUS. It started off being quite open source and really, building up these kind of partnerships between research groups. So some of you are maybe quite familiar with the idea of radio tracking generally. Radio tracking has been around for probably near like 50 years. It's one of the very first tracking technologies that was developed. And we call these kind of old style radio tags, beeper tags, and this just means they are kind of they're uncoded. They don't have a digital code in them, and so you can see these lovely pigeons, or whatever the Microsoft image is, they're all on 147 megahertz. This is their tracking frequency, of all of these tags, but you can see that the last 3 digits are different. So each individual bird has a different frequency. That means you use up a lot of frequencies. It's not very efficient. You have to constantly tune your tracking box to the particular bird that you're trying to find, which means that while you're trying to find that bird, you can't find other birds. One of the really good things about Motus is that the tags they're very, very similar, but they're actually digitally coded. And so you can see these pigeons over here, all on 150.1 megahertz. That is their tracking frequency. So if you have a Motus receiver, you just set it to detect on 150.1 megahertz, and it will pick up everything that's on that channel. You don't have to go and find specific birds. It just does it. It decodes the signal that comes from the tags, and you get the individual identification. One of the other really good things is with the traditional tracking, you really only have a range of about 2 kilometers. That your aerial that you carry around, you can't really see very far with it. The signals that you're trying to obtain cannot travel to your antenna. Your antenna cannot pick these signals up from very far away. But with Motus, it's got a really extended range. On a good day, when the weather is fine and you have no obstructions and all the stars align, we think that you can get about 10 kilometers, which is amazing. And particularly when you think about how small an area a mist net covers. These birds have been captured in a mist net. They've been tagged. They've been ringed. If they had just been ringed, to get them again to record their number as a retrap, you would have to have your mist net in the right place. That's 12 to 16 meters of space. But here, you can kind of get retraps in inverted commas over many, many kilometers with very little effort. So this is a really good thing. And then when you've got other stations, every station works on the same frequency, and so your bird that has just blown off the bottom of my screen has gone past that second receiver, and the signal has been detected ideally by the second receiver as well. So you start to be able to build up pathways. You don't just necessarily have presence absence. You might get a migratory route. This is a small infographic that I made when I was in my first postdoc at Hull, just to kind of explain maybe in a bit more detail how Motus works. I had a vision of creating a Humber estuary Motus network at some point, where I would have more receivers than I've kind of drawn on this little image, to be able to kind of track particularly species that we're worried about. So redshank, and loads of redshank on the Humber estuary. Wouldn't it be really great if we could see how they were moving around their roost sites, and how they were, how they were moving with the tide and things, especially seeing as they seem to be doing some land reclamation still, which is obviously great in a muddy estuary. If we had this nice receiver network, you would be able to see when birds were moving to different sites and what times they were doing this, how long they were spending there, with very little effort. And Motus is big now. Motus is very exciting. So I said it started around 2011, but now this is actually from February this year, I think. We've got 34 countries that are partaking in Motus, over 1,700 receiver stations, and over 44,000 animals have been tagged, which is incredible. There's 700 different projects, so there's so many different research groups that are involved in this. This is what the global network looks like. Each of these yellow dots is a Motus receiver. Each receiver will have between probably 1 and 5 or 6 antennas. Some stations will just have single ones that we call omnidirectional antennas. They just stick up. They don't do direction. They just do presence absence. Most receiver stations have kind of 2 at least directional Yagi antennas. But you can see how biased the network is to the United States and Canada. This is where it started, of course. I don't know if you can see my mouse, my cursor moving over the northeast of the States and the bottom of Canada, but that's where Birds Canada is based, around Toronto. And so you can just see the density of these stations. And there's been a lot of strategic growth. So you can see down the coast of the Great Lakes, to the left of where it says Michigan, by Wisconsin, you can see they've put receiver stations kind of really quite overlapping down the side of the Great Lakes to track species as they move. Then down, if you look down towards Florida, around South Carolina, Georgia, that bit of coast, lots of birds, many different species get kind of funneled down into that bit of Florida for their jump off point at the end towards Cuba and then South America. So there's a lot of kind of strategic thinking that's gone into the growth of the network, kind of regionally and nationally, all at the same time. This is what Europe looks like. It is a bit sparse, isn't it, compared to North America? It is what it is. We are trying, and there is growth. There's growth all the time. So just very recently, hopefully you can see that pink circle that just cropped up above Cornwall. 2 new receivers went up this summer down there. Excuse me. They are very close to Land's End, and we actually have an idea that we might be able to put one right at Land's End, which would be really exciting. Those are University of Exeter owned stations. They're hopefully going to be tagging some blackcaps, some reed and sedge warblers, looking at how migrants are kind of coasting round the end of the country when they get there. And hopefully maybe some yellow-browed warblers as well, if we can get a license to do that. Hopefully you see this other pink circle that's cropped up right at the top of France. They are our first 2 French receivers. They were actually put up by some Belgians who were kind of driving quite a big Nethusius pipistrelle tagging program, just to extend the number of receivers we have down this kind of northwest European coastline. And then lastly, I just wanted to highlight the couple that have gone up in Scotland. Hopefully you can see in Fife, there's one at St Andrews and the university building, and there's one at Crail Golf Club right on the corner of Fife. They are not tagging yet, but there will be a project on rock pipits there, which is really exciting. But you can see the bulk of the receivers are down the coast of the Netherlands. They were funded by a very large amount of money from the Dutch government. And also this kind of area in the Wannsee in Germany as well. They had a lot of money to build that up, but that's been over a decade really of building the German network. Sorry, I forgot I put this in, but here we go. Here's some more detail about the UK MOTUS status. So you can see we've had a kind of a good number of receivers go up in the last couple of years. So the closest one to where you are now is obviously at Bempton Cliffs. Hopefully it's working again now. We had a few small problems with it, but that went up in 2022 or 2023, I can't quite remember. So that joined a cluster of there's one at Spurn, one at Top Hill Low, one at Weldrake, and one at the Deep in Hull. That one is just a listening post. We're not going to be doing any tagging at the Deep, but hopefully the idea is that maybe they can pick up anything moving up and down the Humber. One thing I didn't mention on the previous slide is the receiver at the Calf of Man at the Bird Observatory there. They started a project on northern wheatear juveniles, looking at departure dates and times and things. In July this year, I went over there to show them how to deploy tags, which is really great. We've got a little bit of data. I think we're hoping that some more will come through at some point. We've also got one on Alderney at the Channel Islands. They are hoping to get ready to tag storm petrels. You can see these orange blobs that I've stuck all over the place. They're the most recent receivers, and are all collecting data and doing a really good job at building our knowledge of migration into the UK. There's been some super interesting publications about MOTUS come out. Most of them do come from the States, of course, but it's just to give you an idea of how it can kind of benefit species, really. So there are a couple of key bits in this in the title of this paper. So we've got landscape scale movements, which, as we discussed a few slides ago, you can't really do with the hand tracking, but also snow buntings are very small. We would have no chance of putting a tag on them apart from a geolocator. But then for those of you that are unfamiliar with how geolocator tags work, they're really, really tiny, and they're very cheap, maybe under £100 for a geolocator. But they work with the time of sunrise and sunset, and that means that they can be a little bit out in terms of latitude and longitude. So it's good they're really good for identifying maybe non-breeding areas of species that they're very faithful to their breeding area, and that you can catch them again to get the data. Whereas, with things like snow buntings that actually probably move around quite a lot during the winter, particularly this population in Canada, and also the populations that go up into Siberia, they are making some very big nomadic movements around during the winter. And you can't guarantee that you'll catch the birds again. It makes things very difficult for kind of understanding what they're doing. But this study used the very dense area on the map of North America that I showed you in Ontario. They deployed 40 tags across a really big area, so 300 by 300 kilometers, which is huge. And across that area, there were, in the first winter, 69 motor stations. In the second winter, already 77 stations, which is amazing. This is what the area looked like. It's growing all the time. I imagine there's probably way more than 77 stations there now. We can see that all the red dots are the stations. The yellow ones are the ones where these particular birds that they've highlighted were detected, and you can see they're making these big movements all over the area. So they actually managed to document birds moving cumulative distances over the winter of nearly 1,000 kilometers, which is I mean, migration is amazing, but yet sometimes I'm not surprised now that these birds are making these incredible journeys. But for a tiny little snow bunting in the winter, moving around pretty constantly, to go 738 kilometers is really is very impressive. This is a really nice example of a study where a really hard to track species has, our knowledge of what they do over winter has just expanded massively from one study. Sorry, dry throat. So this is another favorite study of mine, and I think this is a really nice example of how MOTIS is best used. Hopefully you can see this map in the Bay of Fundy in Canada. You've got you can hopefully see the sort of blue circles. They represent MOTIS towers, and then they've labeled all these roost sites of chimney swifts. So a species that very small, very hard to tag, can move massive distances daily and during migration. So their breeding sites are chimneys, clearly very easy to identify, and you can keep an eye on which birds are breeding in which colony. But they used MOTIS to tag loads of different individuals in the different colonies and looked at how they moved between the different roost sites, and they created this really nice social network. So they kind of looked at the roost sites which were the most popular. So you can see on the right hand side of the circle where it says Caledonia, you can see there's loads of links going into that one. So birds are going in and out of Caledonia all the time, and there's a really big exchange of birds with this Upper Clements colony on the left hand side. So this is kind of information that you can go in and ring the swifts. You could even color ring them if you really wanted, although a swift's leg is very tiny and you wouldn't be able to see it in flight anyway. But MOTIS has given us a really fascinating bit of information here about how birds are moving between their breeding colonies. So I mentioned geolocators, I mentioned satellite tags. So what's special about MOTIS? The size is the biggest thing. The smallest MOTIS tags are less than 0.5 grams. The smallest ones that are actually available now are called nano pins, and I think Actually, that's not entirely true. There's a nano pin, I think it's 0.13 grams, and they have tested them on bumblebees. And they are potentially what we're looking at, trying to get a license for yellow-browed warblers. I think they're a bit smaller than the other tags. There are also some 0.06 tags that one of the tagging companies is producing, but it's not entirely compatible. So I'm not going to fully say it's a Motus tag. But it's you can link it up to a motor system. But anyway, some very clever people are making some very, very tiny tags. So this means we can tag some really, really small birds now. This is one of the tags that I use for the black caps, and that's my hand. And I've got quite small hands, so you can see how tiny it is. It really is. It's about 11 millimeters long, and the wire here is the antenna. That's actually quite long. It's about 15 centimeters long. It's very, very flexible, very thin, doesn't get caught in things. Obviously these go on bats as well, and we have to be very, very careful about what we put on bats. The spatial resolution, I vaguely touched on this, talking about geolocators. The receivers are detecting over multiple kilometers, which is great. So we're talking landscape scale tracking data, but instead of geolocators, which they give you this very broad region of sort of vaguely where the bird went based on latitude, longitude. But actually, if you've got receivers at multiple different sites, we're starting to get kind of site level data, which is really useful for conservation. We want to know which sites roosting birds are going to, particularly for waders that might be going to specific sites along their kind of migratory route. We need to know where they're spending the most time, and how it kind of fits into their migratory journey, and Motus really works for that kind of thing. The temporal resolution is incredible. You can set, I set my black cap tags to every 3.7 seconds. So you get a lot of data. But if they're very, very power efficient, the tags. So if you set them to every 30 seconds, you could get over a year's worth of data really easily. The data transfer, you don't need to recapture the bird. You do with geolocators, because they don't transmit data, and also many GPS tags, even though their GPS tags are incredible. They produce some very fine scale, high resolution data, but they are archival as well, and they're also too big still to put on passerines. This is kind of a nice infographic that I made for a recent preprint I put out about Motus. So you can see there's two tags at the top here. These are solar powered Motus enabled tags, just the top two on the left hand side. And then also this one that's labeled battery powered Motus enabled tag. This is kind of where they sit. So you can see they're alongside geolocators in terms of the size, but they also transmit data. So what does a Motus receiver look like? From the outside, really, it's all about the aerials. The aerials are big. There are 150.1 megahertz aerials they're definitely taller than me. Just not saying much. They're probably about 2 meters long. So they're pretty big. And so this is, if you're outside a building and you're looking up at a Motus tower, this is probably what you're going to see. You're going to see aerials and poles and cables. On the top right in the image, we've got a kind of standalone system. It's not mounted on a building. Most of them are mounted on buildings, but this one is at the Calf of Man, and they've got 4 antennas on top of this nice pole construction that can look out over the fields. But you can see it's quite flexible. You can kind of put them on anything really if you try hard enough. We are starting to get people putting them offshore. The bottom right hand, actually both bottom images, where it says offshore monitoring tower, that's actually an offshore tower off the coast of Belgium that was put up by the Flanders Marine Institute a few years ago. I mean, these are some of the questions that I get about Motus. The very, very common questions are, where can I put it? What do I need to put a Motus receiver up? And I think the answer is you can kind of put it anywhere. If you've got a decent line of sight, and you've got a good question that you want to answer, you can kind of put it anywhere. But you do need permissions, landowner permissions and things like that. So the actual receiver is just a circuit board in a box. This is a CTT sensor station. This is, it's kind of you buy it ready-made basically, and you pay for that. You pay quite a lot of money to get a receiver in a box ready-made like this, but they're really flexible systems. You can monitor 2 different frequencies at once. So we use 150 megahertz in Europe. There is also a globally freely available frequency of 434 megahertz, and you can program this receiver to listen to 2 frequencies at once, which is really good because people do use both. We have a very expansive bat tagging study in Devon, and that's entirely on 434 megahertz. So it'd be good if all of our receivers kind of had at least one different frequency aerial on them to kind of monitor these movements. You can also build a sensor node. You can build a Motus receiver yourself. This is it's actually not that difficult to do. You can get all the instructions online. It's all open source. I've done it. You need to solder a few bits together, but it's not that difficult to kind of put the components together. And it's kind of in the spirit of Motus, that kind of mentioned at the beginning. It really is about collaboration. It's about helping people make their systems and kind of get their setups up and running. So what do the data look like? I'm going to show you the raw data in a minute and kind of give you an idea of what kind of questions we can answer. But you can go onto the Motus website and onto this, what we call the Motus dashboard. This is the image that you can see below. This is, there's a wealth of information in there. It's amazing. So obviously you can see a map of Northwestern Europe, you can see the Netherlands in the middle, and you can see a green dot highlighted. So I took a screenshot of this where I selected one of the dots. All of the dots on the screen are receivers, and the green dot is the selected receiver, so it's called Vlieland. It's on the coast of the Netherlands, and when you click on the receiver, it will show you all of the other receivers that it's connected to by detections. So either it's detected a species, an individual bird that was detected first somewhere else, or the bird was tagged there, and then consequently it was detected somewhere else. You could spend all day looking at this map, clicking on all the different receivers and looking what's gone where. If you hover your mouse over the yellow lines, you start to get temporal information. So you start to be able to see how fast birds and bats have crossed the channel, which I always find completely mind-blowing. We've got actually quite a lot of starling data now. Starlings can cross almost between that where that green dot is and the coast of Norfolk in not very long, about 4 hours. It's really quick. We've got records of goldcrests crossing, robins crossing, wheatears, blackcaps. There's a lot of stuff moving across there. It's probably not a surprise to you. We're here talking about migration on Migweek. You know how big it is. But just seeing, what times they leave, what their kind of decisions are, how long it takes them. You can correlate it with weather data and look at kind of how hard a time they had crossing the channel. So yeah, here's an example of that. So you see just in the background, there's the red line. So that's where I've clicked on that line that was yellow and made it go red. And it tells you that it's a Eurasian blackbird. It was tagged on the 11th of November, a couple of years ago. Actually, no, I tell a lie. That's not what this is showing. The start means when it left the coast of the Netherlands, so when it was at the first receiver, and then when it ended up on the coast of Norfolk. So it left the coast of the Netherlands at 8:20 in the evening, and it made it to I think the very north coast of Norfolk, 5 in the morning. So it actually took that blackbird quite a long time. So you can see it's travelled 245 kilometres, an average of 26 kilometres an hour. I would guess from that, because that is quite a long time, it maybe hit some headwinds. It might have even made a decision to go to change its route. Maybe it was initially going further south and then it changed and it went further north. but you can sort of hypothesize about all these things when you're clicking around the map. I would very much encourage you to go and do it. I think it's just absolutely fascinating. When you go into a different section of the Motus website, there's just so much information everywhere, but you can click on particular receivers, particular tags that have been detected at these receivers. This is an example of this is the kind of timeline that you might see. This is actually at Bempton Cliffs. This is a blackbird that was tagged last September. So you can see we've got the 24-hour clock going left to right, and then the dates down the side. So from the 6th to the 13th of September, we tagged it on the 6th. It was kind of around, it hung around. You can see the red patches are the actual detection periods when it was being picked up by the aerial, and then you've got these white blank periods where the bird was out of range. So this bird did hang around for quite a while, even though it moved around the site, it disappeared. Bempton's not the least hilly place. There's lots of sort of little nooks and crannies where a bird can hide out of range of the receiver. But we tagged it early on the 6th of September, and then it finally, on the 13th of December, right at the bottom of the timeline, you can see that the signal finally disappears at just after 7 a.m. And then it's not detected again. So this is the time when it actually left Bempton Cliffs for its migration. So like I said, yeah, loads of data every 3.7 seconds. You almost wonder if it's overkill sometimes, especially when I'm downloading all the data. I think, oh, blimey, this is taking hours to download because you've got, like tens of thousands of detections. But that's really exciting. You've got these really fine temporal scale detections of these tiny birds flying around. And this is kind of it's far more information than you would get in other ways, from ringing. Obviously we can see visible migration, we can see what's going on, but to get this individual level information is really important. I don't know why that Motus logo came up. Yeah, as I mentioned, there's a kind of cluster in Yorkshire. So there's Bempton Cliffs, Top Hill Low, the Deep. This cluster, those 3 receivers were all funded by some money that I got from Yorkshire Water, which is very generous of them. Yeah, that allowed us to put up 3 receivers, each with 4 antennae, and also buy quite a lot of tags, which is really good as well. So they join, as I said, Spurn and Welldrake, which were put in independently. They also funded these really nice interpretation boards. So you can see some kind of nice little infographics about what's happening, and quite a nice image of a blackcap. It's not entirely biologically accurate, I would say, but that's okay. But this is the kind of main project that I kind of started at the very beginning of my first postdoc. It was the first species we got a license to tag Motus with, and that's the kind of the thing that ties quite a lot of the receivers together. So hopefully a little bit about how amazing blackcaps are and how they've changed their migration route, we think, over the last 40-50 years. So we never used to get wintering blackcaps in the UK, but now we get loads of them. And actually it turns out that these wintering birds come from Central Europe, all over Central Europe. They can come from as far east as Poland and probably further, but also just from France as well. And they are, instead of making a southerly movement, they've decided to make a northwesterly movement and come to the UK, which is quite strange. But obviously the UK is a lot warmer than it used to be over winter, and so they're able to survive, and then they're kind of passing this information on to their offspring when they go back to breed in Central Europe. And so we progressively get more and more birds coming over here. But we still don't really know. We still don't really know what the kind of diversity of routes is, which birds from which populations are going to Europe, when the birds come from Europe, where are they coming from? We have some geolocator information, but these, as I said, they highlight very broad regions of Europe and the UK. And you can only really you can only really get this information if you can capture the bird again and remove the geolocator. And actually that's really difficult to do. And it's particularly difficult when you've got juvenile birds, which often won't go back to the same place. We know so little about juvenile dispersal, this kind of post-breeding movement to go and to find your future breeding site, or to explore the region and decide where you're going to come back to the next breeding season. So many juveniles die. So if you put geolocators on a load of juveniles, there's a really high chance that you're not going to get even half of them back. So with Motus, we know we don't need to get them back to get the data. We're not anticipating getting these tags back. This is a one-way deployment. But even if they disappear in a strange direction or they die, we hopefully will still get a little bit of data from them before that happens. One of the really successful other pilot projects that's been happening is, well, it's not a pilot project anymore. It's looking at Nethusius pipistrelle movements. As a birder, I know very little about bats. I know more now than I did 5 years ago when I started working with Motus. But they're absolutely fascinating. I mean, these are the weight of a gold crest. They're tiny 5-6 gram bats, and they go across the channel, as we have now found out. From Motus, they go across the channel to breed. It's mostly the females that go, but we just have no idea really about the numbers that go across and when they're going and how they're making these journeys. And actually, the amazing efforts that the bat workers have gone to with putting Motus tags on them is just amazing. Like, we just have so much more information. And I've put at the bottom more than 20 tagged at Minsmere, Suffolk this spring. Actually, this is from last year. I think more have been tagged this spring, and there's probably 60 odd bats that we have information from now. So the Black Cap Motus project, we tagged 33 in the first year and a half. And then there've been more tagged last September, and then also this year, which is really exciting. So a couple more at Bempton, some at Top Hill. The guys at Stamford Ringing Group were going to be deploying some more tags, but I'm not quite sure what happened. But this is the kind of information that we can get. So this is in the table on the left-hand side of the screen. We've got all the different tag IDs from the first 33, where they were detected for a decent amount of time. Some tags don't ever get detected. It's very strange. There are all sorts of things that can affect whether a tag gets detected. Some of the black caps were never heard from again, and you can see here there's the third and the fourth one. They only got 4 detections each, so it's not very many. But then you can see others, we're into the hundreds of thousands, we're even into 1 million. 58775 has over 1 million detections, over 2 receivers in 17 days. So yeah, it really varies. Here you can see in the middle, a male black cap. You can't see the tag, but you can see the wire sticking out the bottom, so you can see how fine it is. We also take a lot of morphometrics, so we take head and bill, we take tarsus, wing shape, length and weight, and minimal measurements as well. So these are some of the black caps that I was able to do a little bit more with the data. They had enough data for me to look at what they'd actually done when they were departing for migration, which direction they'd gone in. So you can see here there are 2 that were tagged in the spring of 2021. I haven't managed to analyze last year's data or this year's data yet. Yeah, so we've got 2 that were deployed in the spring of 2021, and then the rest were autumn 2021, spread across several different bird observatories in the UK. And just highlighting a couple, 58326 moved from Sandwich Bay Bird Observatory to Dungeness. This one moved from Dungeness to Langard, which is really exciting. 58777 did this. I tagged him at Langard Bird Observatory the 2nd of October, and about 7 days later, he was on the Dutch coast, right at the bottom with the border of Belgium, and then a few days later he'd already made it into Germany, and the last set of detections that you see from this bird is it disappearing east, so it's going even further, which I think, it's just given that we haven't actually tagged that many birds, I think to get a really nice interesting movement like this is really lucky. So it just shows you that even this was a bird that bred or was born in the UK, and it's making an autumnal movement in the kind of east northeast direction, which is I mean, it's just interesting, isn't it? And you can hypothesize about what's going on. So this is what, when you process the raw data, you're basically just getting a set of beeps from this tag. The signal varies, the signal strength varies as the bird is moving around. It can vary because of vegetation, topography, the weather, and also distance from the antennas. So here, this is a detection of a starling at Wheldrake. So you can see along the bottom, we've got time of day. Just before 9 in the morning, the bird approaches the receiver on this first antenna. So here we go, the 87-degree antenna. So it's east facing, it's basically 90 degrees. So it's facing due east. And so you can see these red dots. You can see the signal strength increases just after 9:08 in the morning, and then it decreases again. So the bird got closer to the receiver, and then it got further away again on that particular antenna. Then we can see it was picked up on the 355-degree antenna, which is the north-facing antenna, and the signal was actually a lot stronger on that. So we know that, again, the bird got closer to the antenna and then further away again, but it got much closer. It got closer than the east-facing antenna. So then when I think about how that translates to what the bird actually did, this is the Wheldrake receiver, and this is a representation and a kind of estimation of what the antenna ranges are like, this sort of lobed flower-like shape. And actually, so we know, as I said, it came to the east-facing antenna and then the north-facing one, and it didn't stop, didn't spend any time there. It was all over in a matter of about 4.5, 5 minutes. But this is what we think this starling did. And actually, it was really interesting. So this was, I think it was in December 2022, and we actually had 2 starlings, and they did exactly the same thing. They both made this movement. So I guess they'd come, had been tagged in the Netherlands. Important bit of information. They were tagged in the Netherlands, and then a few days later they appeared going inland and northwest in the UK. So maybe they came ashore around Spurn sort of area, North Lincolnshire coast, and then made this journey across into Yorkshire. One of them, 5 days later, went back to the Netherlands. We've got legitimate detections of it back in the Netherlands, which is pretty fascinating. We know a lot of birds move with the cold, so you get these big influxes of birds from the continental Europe into the UK, where it's much milder over winter. But this bird decided to go back later, which I thought was pretty cool. This is a really nice recent example. I'm showing you exactly the same pattern, basically, different directions that the antennas are facing in. This is a blackcap that was tagged at Top Hill Low on the 7th of September. I don't know if anyone from is very familiar with Top Hill Low or anything is watching, but this was tagged at Top Hill Low on the 7th of September, and then it wasn't actually detected on the Top Hill receiver, which I think is quite interesting, but it was detected 5 days later at Wheldrake Ings, which is great. So we've got this nice little fly past. Again, didn't stop. It's just over the course of 8 minutes, 7:45 in the evening, it arrived at Weldrake. It flew past the north-facing antenna again, and then it hit the sort of west-facing antenna. So it's kind of crossing from the top down to the side. So it's making a southwesterly, generally, movement. So from Top Hill Low past Weldrake, which is pretty cool. Yeah, something like this. Yeah, it's artist representation. Probably not particularly accurate, but the best I can do to show what I mean. With the black caps that I'd had more of a chance to analyze the data from 2021, this is a really nice image. The graph on the left-hand side. This is a classic example of a bird taking off on migration, and this is the kind of information that you just how often do you get this kind of information? This information to the second about what birds are doing. And so just to kind of take you through what's happening in this graph, again, we've got loads and loads and loads of dots. All of these are single detections. Here, you can see there are 4 different colours. So this bird was actually picked up on all 4 of the antennae. This is at Spurn Bird Observatory. It's another nice, reasonably local example. So we've got 4 different colours. Bird was very close to the receiver. So if it's being picked up by all of the antennas, it means it's right there. But you can see that unlike the other images, that it's you kind of have these loose peaks. Actually, here you've got 4 pretty straight lines. This top turquoise color is the strongest. It's got the highest signal strength, so the bird was closest to that side. So the 187-degree facing antenna, so the south-facing one. But it's picked up on all of them, and then so you can see suddenly. We get to about, what do we get to? 21:45, 21:50, 21:55, 5 to 10 at night. There's a little bit of a change in its behavior. Something happens, it moves around. And then you get this huge peak. And that's because the bird's taken off. It was roosting. It wasn't moving. So all this times from 9 o'clock until 5 to 10, this is a bird roosting because you've got no movement in this data. And then all of a sudden you've got these peaks. So the signal strength shoots up as the bird takes off from its roost. It comes out into the clear. The antennas have got a good line of sight at the bird. And so they all increase, and you've got this big peak because the bird just takes off and he leaves. And then as soon as it's peaked, it's gone again because the bird moves very, very quickly off from the site. And it actually departs. You can see the purple antenna is the last one to pick it up, 345 degrees. So it's pretty much, it's north. You think about how the coast goes at Spurn. To the north of Spurn, it's kind of, yeah, it's basically northwest. So the bird takes off. It's last detected on that receiver. It's flown north. This was in the spring, so that makes more sense. It was a male around the 8th of May, I think it was tagged. Yeah, it actually, we tagged it around the 8th of May, and it spent about 13 days at Spurn, and then it decided to suddenly take off. So it'd be really interesting to look at what the weather patterns were like, and it would be great, if we had extra weight data on this bird to see, like, oh, did it put on weight, and then it suddenly decided the weather was good, it was a good weight, and it decided to move on with its migratory journey, and we don't quite have that information. Here's another departure. You're probably fed up of seeing dots on screens. It's another classic peak departure of a bird at Sandwich Bay. The bird again is kind of roosting. It's the evening. This was in the autumn. 7 o'clock at night, the bird starts to move a little bit more. You see an increase in these purple dots. So that's a more northerly facing antenna, but then the real peak is on the 31-degree antenna, so the east-ish. Yeah, northeast. Lost my compass points in my head. And then the last antenna that's detected on is 153 degrees. That's actually southeast. So it's the autumn. And we're at Sandwich Bay, so we're on the coast, on the southeast of England, and the bird takes off in a sort of southeasterly direction off towards France, which is what you would expect. You can put all this information together, and you can create this nice compass with all these sort of these dots. We're we can start to look at what the average of all these birds are doing. This arrow in the compass is the average of all these birds leaving Landguard Bird Observatory in the autumn. The one that I've highlighted in green is the one that went to Germany. That actually didn't depart. It didn't leave and just fly off east to the continent straight away. It actually disappeared to the west. And you can see, if you look to the map on the right hand side, you've got this green line that's kind of pointing inland. That's that bird. So it didn't make this big kind of jump off from Landguard. It went inland first of all. My guess would be that it followed river estuaries and followed the coast kind of down to the Thames or something, or down to even then down into Kent, where you've got this very, very short distance across the channel, and which would make sense, in terms of energy and things like that. Obviously, not all birds do that. They make big journeys, birds that have been detected at Spurn that have come from the Netherlands that have just done that cross-channel journey all in one go. Then they're not all going to go for the shortest route, but I have a feeling that maybe that's what this bird did. Yeah, we also did tag one bird in spring at Landguard, and she made this nice. She's the red line on the map. She went northeast in spring, so that's nice. Sometimes they do what you would expect, I guess. The majority probably do, but then you get those nice movements like the bird going into Germany. Yeah, you can make more compasses with lots of colours. So kind of to wrap up, I spent quite a lot of time thinking strategically about Motus and about how we're going to get money and how we're all going to work together, because, like I said, it's not for one person to do. I want to work with as many people as possible. I want to work with people from every country in Europe, because this is the only way we're going to be able to get to a point where we have a really nice, coherent network of receivers across the continent. This is an image that I made for the preprint, the publication that I put out recently. It's waiting to be properly published, but hopefully it'll get there really soon. And I wanted to kind of give an idea of where we should be targeting in a way. It's not entirely my opinion alone. There are quite a lot of co-authors on the paper, and we kind of had discussions and shared ideas about where we thought it would be best to put receivers. There are so many questions that we could answer with Motus. So for instance, looking at the border between Spain and France, you've got it's not really necessarily a pinch point, but we know loads of birds go down the Bay of Biscay, and they come into that corner with Basque Country, around Bilbao sort of area. We could put lots of overlapping receivers in that kind of corner right across the border between France and Spain, quite a mountainous area. Birds will be probably potentially using specific routes, that we could hope to capture by having this big fence across to maximize the area that's actually covered by the detection range of the antennas. Thinking about things like the yellow-brow warbler, we think it's probably got a wintering area somewhere, that's been building for a while, down in in the Canary Islands or something like that in Spain. So putting this kind of set of receivers around the tip of France, as I've kind of put there. It's directly south of Cornwall. This very tight kind of coast area that we could flood with receivers and get quite a lot of detailed information about what kind of vagrants and normal migrants are doing when they hit that kind of Land's End. Like we could do that in Cornwall as well. I think there are so many questions, and at a kind of regional scale, because we can't just think about what we're going to do across Europe as a whole. We can't just suddenly have all these receivers, and one of the ways to build the network is kind of thinking quite regionally, in the way that we've got this 3 receiver cluster, Top Hill, Bempton, the Deep, thinking bigger than that, but kind of landscape scale sort of studies, but building them from that scale upwards. So maybe thinking about actually, well, this breeding site of for example, nightjars, which I think would make a great motus candidate. They're very lightweight, very mobile. I'd like to put lots of motus receivers across their breeding sites, where I did my PhD at Hatfield and Thorne, but also the North York Moors, where we've got growing populations, or they were growing very quickly, certainly. I'd love to look at their dispersal. So I'd love to have different, several receivers in Dalby and in Cropton, and, look at kind of the interchange between birds and where they move, post-breeding dispersal, post-juvenile dispersal, where they're going. And, so even though I'm putting those receivers up potentially for a specific purpose, because they're all monitoring on the same frequency, they contribute to the network as a whole, so they're up and they're running and they're very cheap to maintain. It's capital expenditure to put them in, but cheap to maintain, reasonably low overheads and things like that. So we anticipate that all the receivers that are up at the moment, that we're talking about decades of use from them. They need software updates and they need tinkering with, and they need bits replacing here and there. But we should be thinking of these as like long-term installations to answer long-term questions about bird migration and bat migration. And I hope that the paper that is going to come out with colleagues from across the Netherlands, Germany, into Hungary, and Sweden. I hope that this will act as a kind of catalyst to really get different research groups across Europe thinking about how we can all work together to build this network. So thank you very much for listening. It's very weird because I can't see anybody. I don't know if you've all fallen asleep. What's going on? Hopefully you found that interesting. If you've got questions, even if you don't have any questions that you want to ask right now, please do get in touch. I'm on Twitter, and you please use my Ghent email. I'll certainly try and get back to you. If you have questions about putting up a receiver, or questions about migration, things like that. But yeah, thanks very much.
Lucy, that was fascinating. I can guarantee that the two people in my household haven't fallen asleep, so we've been watching with great interest, and yeah, that's fantastic. Thank you. Yeah, we have a few questions coming that have been pinged through to me, so I'll take them from the top if I may. Somebody asked how long a tag transmitted for. I noticed you flagged on a graph it was into years, but I just wonder what variation you have in that.
Yeah, so the tags, you can make them last for multiple years, and actually now they have solar powered ones that in theory could last the life of the bird. So they call them life tags. And we've sort of discussed those in the context of swifts, that actually live quite a long time, and you could get multiple migrations from them. If you can attach the tag with a harness and it's got a solar panel, then you could be looking at multiple years of data. I mean, the way that I set up my black cap tags, they were going off every 3.7 seconds, and because the battery is obviously very tiny and they don't have a solar panel, they probably last about a month. I wasn't anticipating they would last longer. I just wanted to get this kind of departure information, this very early migratory period. So for my purposes, it didn't really matter. If I'd wanted it to last for longer, I could have set it at maybe every 10 to 20 seconds, and got, multiple months of data. But actually, I think because of where you have to think about the question that you're asking, and black caps are probably going to go somewhere where there aren't that many receivers. They're either going to go south, Southern Europe, there are no receivers there. Eastern Europe, there are no receivers there. So there's no point in setting it for longer, if you see what I mean. So, but yeah, they're very, very flexible, and you can kind of make them last for how long you need them to last for.
Presumably the receivers are quite expensive, are they?
Yeah, all in, we generally say about £3,000. That includes the poles, the cables, the antennas. If you are very kind of technical, I think, and very confident about your ability to scale the side of a building, for example, and put it up yourself, you could probably save quite a lot of money. Um, but I mean, and it also varies. If you build it yourself, you can build it for a couple of £100. If you buy the ready-made one in the box, that's about $900. So it's about £600 or something. I don't know. I'm not sure what the exchange rate is now. But it's yeah, let's say twice the cost. But yeah, I generally say about £3,000, £4,000.
That's interesting. It's quite interesting your map at the end. There was because one or two people have pointed out the potential for offshore wind farms, and people have mentioned
Yes.
lighthouses and things like that. Um,
Yes, yes, absolutely. Yeah, offshore stuff. The Germans are doing a bit about that, and the Dutch. They've got had lots of money from the government or offshore wind companies, and they deploy them. They kind of co-deploy them with acoustic recorders. So you've got kind of two different scales of information. But yeah, I agree that yeah, that would work very well.
yeah, and offshore wind, as you just touched on, has got quite a lot of funding associated with it for such things.
Yes, yes, yes. It's not a poor it's not a poor area.
No, no, probably looking for projects that they can fund as well. So,
Exactly.
yeah,
Yeah, yeah, yeah.
yeah. Um, that touched on government funding. So, do you actually get any help from any of the agencies or the UK government towards this at all?
No, no, nothing at all. No. Yeah, it's something that I think you I have occasionally spoken to people from um from Natural England, particularly Nature Scott, a couple of times when I was up in Scotland. Individual people are very interested and obviously can see the application of it, but to get that kind of broader funding is so difficult. And obviously, with all the cuts over the last couple of decades, there's almost no chance of getting money for stuff like that, which is, yeah, it's a shame. Because I think it could answer lots of different questions. I think the most interested party actually that we've had over the last few years has been the National Trust, interestingly enough, and kind of thinking about seabirds on the Yorkshire and Northumberland coast. That had vague discussions about that, where they've actually asked me to cost stuff up and think kind of strategically about and tactically about how we would go about getting the birds and tagging the birds. But yeah, I think trying to get that broader help from a cash-strapped agency is very, very difficult. And now I've moved, which doesn't help.
Yeah, indeed. Um, a final one. Somebody else was observing the map, so it was interesting that there was obviously big gaps in France and Spain, as we know, a quite important flyway into Africa, particularly from Western Europe. So it's interesting to see that you're obviously targeting those. Yeah, it'd been flagged before you brought that map up, so it's interesting that that's obviously something that's very much in focus.
Yeah, absolutely. I think the good one of the things about Motus, that I kind of say to people when they're thinking about how could I use it in my research, or what kind of studies could we do with Motus. It's very good for species that you kind of know a little bit about, but you don't have the more detailed information. So for example, there's lots of species, and yeah, we know they take a westerly flyway through Europe. So they go through France and they go through Spain and into Africa that way. And then we've got the other ones that go through Italy and through Greece and down that way. Um, and but we don't have really detailed information because that's just not the scale of the data that's been collected on these small birds. And actually we could use the information that we do have from geolocators about, the sort of broad regions that they go to, the south of France, the Bay of Biscay down into Spain and then Gibraltar. To position Motus receivers to then get that more detailed data about exactly where they're stopping and exactly how long they stop for, and how they make it across from Spain to Africa, that kind of thing. I think we have some information from some species that would allow us to build this map essentially. If we had £1 million, or more like £10 million. But yeah, I think there are obviously certain areas that would be really good to target. These kind of pinch point areas, really starting to understand how birds congregate there and how that might influence population dynamics and things like that, how long these species stop for and what happens to them after that, and we might even be able to find points where we see lots of birds arrive, but then the detections of them departing are never captured. And actually, are we seeing a hunting area? Are we're seeing mass mortality or something like that? That's far into the future, where we've got hundreds of birds being tagged in, and and really good kind of rates of detection and stuff. But I think that's the kind of thing we should be aiming for, really. To get that, we need that information, and we don't have it in order to conserve all of these migratory species.
It's a great place to end there, I think. Yeah, very much so. I should have said earlier on an announcement that the traditional side of ringing is definitely happening tomorrow at the South Landing. So from 8 o'clock in the morning till 12, there'll be ringing demonstrations to anyone who wants to come along. So that side of things, less technologically advanced, but that side of things is still happening at Flamborough tomorrow. So thank you very much, Lucy. Really, really appreciate that presentation. I'm sure a great many do as well, and it's been fascinating. So thank you very much.
You're very welcome. Yeah, you're very welcome.
Well, thank you so much. That's fabulous.
Thanks, Lucy. Yeah.
Yeah. Oh, you're welcome.
I think it all went smoothly, hopefully.
Did it?